Let me begin with something that sounds dramatic. What if the first person who goes to Mars never truly comes back? Not because of an explosion, not because of a failure, not because of a failure, not because of some Hollywood disaster, but because physics quietly makes the return far more fragile than we like to admit. We talk about going to Mars as if it's a long camping trip, a bold adventure, a new frontier. We imagine rockets launching, flags planted, triumphant returns. But space does not care about our excitement. Mars is not just far. It is unforgiving, and when you truly understand what it takes to go there and to come back, you begin to see something deeper. Not fear, not pessimism, but respect for the brutal honesty of the universe. Let's think simply. Mars is, at its closest, tens of millions of kilometers away. That's the closest. Often it is much farther. The distance between Earth and Mars is not fixed. The planets move. Sometimes they're neighbors. Sometimes they're on opposite sides of the sun. So a trip to Mars isn't like driving to another city. It's like trying to hit a moving target while both you and the target are racing around a giant fireball at enormous speeds. Already the complexity grows. Now imagine you're inside that spacecraft. For months, not days, not weeks, months, in a small metal cylinder. No fresh air except what you recycle. No real gravity. No open sky. No quick rescue. If something goes wrong halfway, you cannot turn around easily. You are committed, like a ship in the middle of an ocean with no land in sight. But far worse because there is no water, no air, no anything outside your hull. Just vacuum. Now here's the first hidden truth. Leaving Earth is hard. Coming back is harder. When you leave Earth, you are climbing out of a deep gravitational well. Earth's gravity holds you tightly. It takes enormous energy just to escape. But Mars has gravity too. Smaller, yes, but real. Too real. So to come back, you must launch off Mars, escape its pull, align yourself with Earth's orbit, and survive re-entry into Earth's atmosphere at extreme speed. That means your mission must succeed twice. The first success gets you there, the second success brings you home. And space missions are not forgiving of small errors. On Earth, if a car engine fails, you pull over. In deep space, there is no shoulder on the highway. But that's just engineering risk. Let's go deeper. Mars is not Earth. It has almost no magnetic shield. Earth has a magnetic field that wraps around it like an invisible armor, deflecting dangerous radiation from the sun and deep space. Mars does not. That means anyone living on Mars is exposed to higher levels of radiation, day after day, month after month. Radiation is invisible. You don't feel it. You don't see it. But it damages cells. It damages DNA. It increases the risk of cancer. It slowly erodes biological systems. Now imagine spending not just months traveling to Mars, but perhaps years living there before a return window opens. Because here's another quiet truth. You can't leave Mars anytime you want. You must wait for the planets to align properly again. The geometry must be right. Otherwise, the energy cost becomes enormous. So if you miss your return window, you wait. And wait. And wait. And wait. And wait. Space is not on your schedule. Now let's talk about the human body. Our bones expect it. Our muscles expect it. Our fluids expect it. In low gravity, bones lose density. Muscles weaken. The body changes in ways we are only beginning to understand. Months in low gravity already cause measurable deterioration. What happens after years? We don't fully know. That's the honest answer. And that uncertainty matters, because returning to Earth means re-entering full gravity. Your body must readjust. Your heart must pump against stronger forces. Your skeleton must carry weight again. There is no guarantee that adaptation goes smoothly. Now here's something even more subtle. Psychology. We underestimate isolation. On Earth, even in remote places, you can step outside. You can see sky, trees, oceans. You can talk to someone in real time. On Mars, communication with Earth has delay, several minutes one way. Conversation becomes strange. You speak. You wait. You hear the reply later. It's not a dialogue. It's an exchange of recorded messages. That changes how human connection feels. And if something catastrophic happens on Mars, Earth cannot help quickly. You are on your own. Completely. Let me say that again because it matters. You are on your own. That kind of isolation has never been experienced at planetary scale. Even Antarctic researchers can be evacuated eventually. Mars offers no evacuation. Now here is where physics becomes philosophical. Why is Mars so hard? Because the universe enforces distance. Distance is not just empty space. It is energy requirement. It is time delay. It is risk accumulation. Every kilometer adds complexity. Every day adds probability of failure. We like to imagine that technology will solve everything. And technology is powerful. It has transformed our world, but technology does not repeal physical law. It works within it. The energy needed to move mass between planets is enormous. The margin for error is tiny, and every system you build must survive vacuum, radiation, extreme temperature swings, micrometeorites, dust storms. Mars has dust storms that can engulf the entire planet. Think about that. An entire planet wrapped in dust. Solar panels become less effective. Equipment degrades. Returning home requires all those systems to function perfectly at the critical moment. Now here's the deeper layer of the title. When I say never come back, I don't necessarily mean physically impossible. I mean existentially transformative. Suppose you go to Mars and return safely. You will not be the same person. You will have lived months or years in an alien world. You will have experienced a kind of separation from Earth that no human has known. You will have seen Earth as a distant star. That changes you. There is something psychologically irreversible about leaving your planet. For the first time in human history, someone will look at Earth not as home beneath their feet, but as a tiny dot in the sky. That perspective is not temporary. It reshapes identity. So even in the best-case scenario, the person who comes back is not the one who left. Now let's zoom out further. Why are we so determined to go? Is it survival, adventure, pride, curiosity? Perhaps all of these. There is something noble about exploration. It defines humanity. But physics forces us to confront a sobering truth. Planets are not stepping stones waiting for us. They are harsh, indifferent environments shaped by billions of years of processes that do not care about human comfort. Earth is not normal. Earth is rare. Its magnetic shield, atmosphere, liquid water, stable climate. These are precious. Mars is a reminder of how fragile habitability is. Maybe the deeper lesson of Mars is not that we must conquer it. Maybe the lesson is that we must understand and protect what we already have. Going to Mars is possible. Perhaps even returning is possible. But the cost in energy, risk, biology, psychology is enormous, and the universe does not lower that cost for dreamers. It demands payment in physics. That is not cruelty. That is consistency. And consistency is what makes science reliable. If gravity worked differently when we were ambitious, we would not have stable planets. If radiation weakened when we felt hopeful, stars would not shine properly. The universe is impartially, and that impartiality is both terrifying and beautiful. When we talk about the first humans on Mars, we should not speak casually. We should speak with humility, because they are not just travelers. They are participants in one of the most extreme experiments humanity has ever attempted. And whether they return physically or not, something fundamental will have changed. Perhaps that's the hidden truth. Mars is not just another destination. It is a boundary between planetary life and interplanetary existence. Crossing it is not a vacation. It is a transformation, and transformation always carries risk. So will anyone who goes to Mars never come back? Dr. Simplest physical sense. Maybe some will return. But in the deeper sense, the biological strain, the psychological shift, the irreversible perspective change, no one truly returns unchanged. And that might be the most honest answer physics gives us. The universe allows exploration, but it does not promise comfort. It allows ambition, but it demands respect. And maybe the greatest courage is not in pretending the journey is easy. It is in understanding the cost and choosing to explore anyway. So the next time you see a rocket launch toward Mars, don't just see fire and triumph. See the delicate dance of gravity, radiation, energy, biology, and time. See the fragile bubble of life carried into a hostile void. And ask yourself a deeper question. Are we trying to escape Earth vibe? Or are we trying to understand our place within a universe that sets its own rules? Because in the end, Mars is not just about distance, it's about perspective. And once humanity crosses that red horizon, whether we return or not, we will never look at Earth the same way again. Let's continue, because the real warning is not about rockets failing or fuel running out. It is about something quieter, but into the structure of planetary motion itself. You see, going to Mars is not like booking a flight where planes depart every hour. The Earth and Mars dance around the Sun in their own rhythms. Sometimes they are positioned in a way that makes travel efficient. Sometimes they are terribly misaligned. There are narrow windows when the energy required is manageable. Miss that window and the price rises sharply. So imagine you are on Mars. Something small goes wrong. Not catastrophic, just a delay, a damaged component, a minor systems issue. You cannot simply say, let's leave tomorrow. You might have to wait many months for the next favorable alignment. And during that waiting period, everything must continue functioning perfectly: life support, power systems, radiation shielding, food production. On Earth, redundancy is easy. We have entire industries behind every small object we use. If a part fails, we order another. If a crop fails, food comes from somewhere else. On Mars, there is nowhere else. It is survival. And true self-sufficiency is far more difficult than we like to admit. Now let's think about gravity again. Mars has weaker gravity than Earth. That sounds pleasant at first. You could jump higher, carry heavier objects, move more easily. But gravity is not just something that pulls you down. It shapes your biology. Your bones rebuild themselves in response to load. Your muscles maintain strength because they must resist weight. Your heart pumps in a system designed around Earth's gravity. Lower gravity changes that balance. Months become years. Years become permanent adaptation. Then imagine returning to Earth. Earth does not compromise. Its gravity will greet you exactly as it always has, becoming and desaud of abad, becoming low at long-term low gravity does to human development, to aging, to reproduction. These are not small questions. These are not small questions. It's are not small questions. They are fundamental biological uncertainties. And uncertainty in space is amplified by distance. Now let's talk about something even less dramatic but equally powerful. Dust. Mars dust is fine, pervasive, and chemically reactive. It clings to surfaces. It infiltrates seals. It coats equipment. Imagine living in an environment where microscopic particles slowly invade everything. Machinery degrades. Seals wear out. Air filtration systems strain. And remember, every replacement part must either be brought from off at enormous cost or manufactured locally under extreme constraints. Small degradations accumulate. Space is not defeated by a single dramatic failure. It wears you down, gradually, relentlessly. Relentlessly. Now here is another hidden layer. Return requires not only surviving Mars, but launching from it. Launching from Mars is difficult. Launching from Mars is different, but still demanding. You must manufacture or transport fuel. You must maintain a launch vehicle in harsh conditions for months or years. You must trust that after exposure to radiation, dust, temperature extremes, and mechanical stress, that vehicle will ignite flawlessly. There is no roadside assistance on Mars. There is no second rocket waiting nearby. When you light that engine, it must work. The margin for error is microscopic, and physics does not negotiate with margins. Now I want to step back from mechanics and look at something deeper. Why does this challenge feel so immense? Because we evolved in a planetary cradle. Earth is not just where we live, it is integrated into our biology. Its gravity shaped our skeleton. Its atmosphere shaped our lungs. Its magnetic field shields our DNA. Its oceans regulate its climate. We are not visitors here. We are products of this world. Mars is not our sibling planet in the biological sense. It is a foreign environment. And adapting to foreign environments is not simply a matter of engineering. It is a matter of time. Evolutionary time. And evolutionary time does not operate on mission schedules. Now here is the philosophical twist. Perhaps the deeper reason anyone who goes to Mars will never truly come back is not just physical. It is psychological and existential. Imagine standing on Mars and looking at Earth as a pale star. When astronauts went to the moon, many spoke of a cognitive shift. Seeing Earth from afar dissolved political boundaries in their minds. It made humanity feel unified and fragile. Now multiply that by distance. From Mars, Earth becomes even smaller, even more delicate. You begin to realize that every person you have ever known exists on that tiny point of light. All history, all culture, all conflict, all love, compressed into a distant dot. Once you have that perspective, how do you return to ordinary life unchanged? You cannot. Perspective reshapes identity, and perhaps that is the most irreversible journey of all. Now let's consider time again. A Mars mission might take years from departure to return. Years during which Earth continues evolving. Technology advances. Politics shift. Families change. Children grow up. The returning traveler steps back into a world that moved forward without them. In that sense, even if you physically land back on Earth, you are slightly out of phase with your own timeline. You left one version of humanity. You return to another. Space travel subtly separates you from your origin. And the farther you go, the greater that separation becomes. Mars is close compared to other planets. And yet even Mars introduces this temporal drift. Now imagine future generations contemplating journeys even farther. The scale of separation grows. The emotional cost grows. The physical demands grow. The universe does not forbid travel, but it scales difficulty with distance in a way that is almost poetic. Each additional step outward multiplies the challenge. Energy grows. Time grows. Risk grows. Isolation grows. And perhaps this scaling is not accidental. Perhaps it is simply the natural geometry of a vast cosmos. The farther from home you go, the more you must carry with you. Life support, psychological resilience, redundancy, community, hope. Mars is the first true test of whether we can carry a self-contained fragment of Earth across space. Not just machines, but ecosystems. And ecosystems are delicate. They are networks of interdependence. On Earth, those networks evolved over billions of years. On Mars, we would attempt to compress that complexity into controlled habitats. One failure in a closed ecosystem can cascade. Balance is fragile out. Now here's the quiet question beneath all of this. Should we go? Physics does not answer that. Physics only describes constraints. It tells us what is hard. It tells us what is dangerous. It tells us what demands extraordinary preparation. The decision to go is human. We are approaching a threshold where the dream of Mars becomes technologically plausible. But plausibility is not simplicity. Feasibility is not triviality. The laws of nature remain unchanged, and those laws will test every assumption we make. So when someone says anyone who goes to Mars will never come back, do not hear doom. Hear a reminder that exploration is not romance alone. It is confrontation with reality, with radiation, with distance, with time, and with ourselves. Perhaps some will return safely. Perhaps technology will rise to meet these challenges. But even in the most optimistic scenario, something irreversible happens when humanity steps onto another planet. A psychological boundary breaks. A new chapter begins. And once that chapter opens, there is no returning to the innocence of being purely earthbound. We will have crossed a conceptual horizon. Mars is not just a location. It is a mirror that shows us how rare Earth is, how delicate life is, how strict physics is, and how bold human curiosity can be in the face of those truths. So maybe the hidden truth is this. The journey to Mars is not only outward, it is inward. It forces us to examine our limits, our motivations, our responsibilities. And once we have seen ourselves from another world, we cannot unsee it. Whether or not the astronauts physically return, humanity will have changed. And that change, like gravity and radiation and distance, will not reverse. Because the universe allows movement, but it does not allow erasure. And when we reach for Mars, we are not just reaching across space. We are reaching across a boundary in our own story. And once that boundary is crossed, we will never be exactly the same again.